Hello friends, the topic for today is 8254 modes of operation. The 8254 has three independent 16-bit counters which can be programmed to work in any one of the possible 6 modes. Each counter has a clock input, gate input and counter output. To operate a counter, a count value has to be loaded in the count register, gate should be tied high and clock signal should be applied through clock input. The counter counts by decrementing the count value by 1 in each cycle of clock signal and generate output depending on the mode of operation. In last video, we have discussed the architecture of 8254 Programmable Interval Timer. In today's video, you will learn the 8254 modes of operation. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe to our channel and press the bell icon to get notifications about future videos. The topic for today is 8254 modes of operation. Let us see the modes of operation. Here we have 6 modes: mode 0, mode 1, mode 2, mode 3, mode 4, mode 5. The modes of operation are: mode 0 is interrupt on terminal count, mode 1 is hardware triggers one shot, mode 2 is rate generator, mode 3 is square wave mode, mode 4 is software trigger strobe, mode 5 is hardware trigger strobe. The initialization procedure for each mode is almost same, but the output of each mode will be different. To initialize a counter, the following steps are necessary. First, write a control word into the control register, and second, write count value in the count register. Then the writing of count value depends on the control word. There are three possible choices. They are: if control word is framed for writing LSB only, then write LSB alone. If control word is framed for writing MSB only, then write MSB alone. If the control word is framed for writing LSB first and MSB next, then write LSB first and then MSB. This is for 2-byte count. In all modes, gate signal acts as a control signal to start, stop and maintain the counting process. Then let us come to the mode 0, interrupt on terminal count. Mode 0 is typically used for event counting. After the control word is written, out is initially low and will remain low until the counter reaches 0. Out then goes high and remains high until the new count or new mode 0 control word is written into the counter. Then gate 1 enables counting, gate 0 disables counting, gate has no effect on out. See, out is nothing but the output of the counter. It will enable the counting or disable the counting, but the output of the counter will be different. So let us see the operation with the timing diagram. So this discussion will have the timing diagram. After the control word and initial counts are written to a counter, the initial count will be loaded on the next clock pulse. This clock pulse does not decrement the count, so an initial count of n out does not go high until n plus 1 clock pulses after the initial count is written. Therefore, in the first clock pulse after WR goes high, the 8254 loads the count value in the counter register, and in each subsequent clock pulse the count value is decremented by 1. When count becomes 0, the output is asserted high. So this is what we'll have to say. If you want to write the mode 0 operation, these are the things you have to include in that, along with the timing diagram. So this timing diagram, you can see the first part of the timing diagram is for the discussion we have done. So here the control word is 10 and the count is 4. and only we are using the LSB, and this is the clock signal, and the gate signal is shown, it is high, assumed to be high. So here, after loading of the control word and the count, the out is say low initially. So here n means it is undefined count. Here it is loaded, so you can see the count is 4. So this the LSB of the count, and this is the 0 is the MSB. So this, now the decrement of the count will start after this on the next clock pulse. So it will 4, it will now become 3, 2, 1, and when it becomes 0, the out will be high, and this signal can be used to interrupt the CPU. That's why we say output on terminal, interrupt on terminal count. So output will become high after the n plus 1 pulses. So after loading of the count, say 1, 2, 3, 4, 5, so this will become high. Then these two waveforms are for the next discussion, which we'll do and then see the waveforms. If new count is written to the counter, it will be loaded on the next clock pulse and counting will continue from the new count. If initial count is written while gate is 0, it will still be loaded on the next clock pulse. When gate goes high, out will go high, n clock pulses later. No clock pulse is needed to load the counter, as this has already been done. So if the gate is 0, it will take the count, but the counting will start only when gate goes high. You can see now the second waveform. Here the count is loaded with count is 3 and the control word is 10, and this is the clock. Now the gate, here gate is going low. So when the count is loaded, the count is 3 here, and the counter will start, it will decrement to 2, and now here the gate has gone low, so the counter will stop, it will not decrement. So you can see the count is 2, 2 here. Then when gate goes high, now the count has decreased to 1, and when it becomes 0, this out will be high, and this can be used for interrupting the CPU. And in this last waveform, this is for the new count. So the first count is 3, second count is 2. This is the clock, the gate is high, and now you can see the out, it is 3, then 2, 1, it is decrementing here. Now here we are loading the second count 2. So when it is loaded, the counter value will become 2. Then it will start decrementing from 2. So 1, then when it becomes 0, this will become high. So this is how the mode 0 will operate. Here we have given some notes here. We are using the binary, not BCD counting, and the counter is always selected. CS is always low, and CW stands for control word, and LSB, least significant byte. So this is, you can just go through that. Then next mode is mode 1, hardware retriggerable one shot. In mode 1, the counter functions as a retriggerable monoshot vibrator, that is one shot. Again, the out will be initially high. The out will go low on the clock pulse following the trigger to begin one shot pulse, and will remain low until the counter reaches 0. So here the initially the out will be high and will remain low for, say, begin with the one shot pulse. Then out will then go high and remain high until the clock pulses after the next trigger. Now when we are looking at the timing diagram, we will have this discussion. After writing the control word initial count, the counter is armed with the count. Then a trigger results in loading the counter and setting out low on the next clock pulse. Thus, the starting of one short pulse. An initial count of n will result in one short pulse of n clock cycles. One shot is retriggerable, hence out will remain low for n clock pulses after any trigger. We can retrigger the say for generating again and again. The one shot pulse can be repeated without rewriting the same count into the counter. Gate has no effect on the out. Let us see the waveform. So now you can see the control word has changed to 12 and the count is 3. This is the clock. Now gate, we are using it as the trigger. So out is high initially. Now when we give the trigger, the out goes low and the counting will start 3, 2, 1. And then when it becomes 0, it will go high. So you can see for here for the 3 pulses the out is low. So that is the mono shot, and then it becomes high. The counting will still go on, so it will become 0. After that it will decrement, it will be FF. And then when we again give the trigger, the counter is loaded with 3. So you can see here 3, then it will be decremented to 2 and so on. So this will be repeated. Then these waveforms are for the next two conditions, that is the triggering when the count has not expired. So here you can will discuss first and then see these two waveforms. If new count is written to the counter during one short pulse, the current one shot is not affected unless the counter is retriggered. In case the counter is loaded with new count, the one shot pulse continues until the new count expires. So here you can see, here the count is 3, control word is 12, then here we are giving the trigger. So the decrementing will start and this here out is low. Now again we are given another trigger, but here the count has not become 0, so it will not become high. So instead of that, again the same count is loaded, so 3 will be loaded here, then 2, 1, and now when it becomes 0, this will go high. So this is retriggering. Then here we have taken the new count, that is old first count is 2, second count is 4. So when we give the trigger, the counting will start, so 2, 1, and then it will become 0, so we will get the low pulse and then it will become high. The counting is still going on, but when we retrigger, the counter will be loaded with the new count, so 4, 3, like this. Let us see the mode 2, that is rate generator. This mode functions like a divide by n counter. It is typically used to generate a real-time clock interrupt. Out will be initially high. When the initial count has decremented to 1, out goes low for 1 clock pulse. Out then goes high again. The counter reloads the initial count and the process is repeated. So here in this case, the out will be initially high and it will go low for 1 clock pulses when the count becomes 1, and again it goes high. So this will be repeated. So mode 2 is periodic. The same sequence is repeated indefinitely. For an initial count of n, the sequence repeats after n clock cycles. So after writing the control word and initial count, the counter will be loaded with the next clock pulse. The out goes low n clock pulses after the initial count is written. This allows counter to be synchronized by the software also. Then writing new count while counting does not affect the count counting sequence. If trigger is received after the writing a new count but before the end of the current period, the counter will be loaded with the new count on the next clock pulse and counting will continue from the new count. Otherwise, the new count will be loaded at the end of the current counting cycle. So in mode 2, count of 1 is illegal. So we should not use count of 1 because when the count becomes 1, then the output is changing. So let us see the waveform. So here the control word has changed to 14 now, and the count we are taking as 3. This is the clock. The gate is high, so out is initially high, and when the count is loaded 3, so here it is undefined, and then here it is loaded 3. The counting will start. It will become 2. Then when it becomes 1, you will get the low pulse. And again, the count the register is loaded with 3. Again, the counting will start 3, 2, 1. When it becomes 1, again we will get the low pulse. So this will be repeated. So that's why this mode 2 is periodic. Then in second case, the gate has become low during this. So if you see here, the count is 3, so it is loaded here and it is decrementing. So now as soon as the gate becomes low, the counter has stopped decrementing, so it is 2 here. Then when gate becomes high, the count as will not continue. Instead of that, again the 3 is loaded into the count register, then 2, and then when it becomes 1, then we will get the pulse. Then in the third case is the new count. So LSB is equal to 4 is the first count, LSB is equal to 5 is the second count. So in this case, you can see the out. It is high. Now the counter is decrementing 4, 3, 2, 1, and you will get the pulse, low pulse. And then immediately the count 5 is loaded here. So it will start counting from 5, then it will become 4, 3, like that. It will continue. So this is the mode 2 of operation. Then mode 3, that is square wave mode. Now mode 3 is typically used for baud rate generation. So mode 3 is similar to mode 2 except that the duty cycle of the out will be initially high. When half of the initial count has expired, out goes low for the remainder of the count. So exactly you will get the square wave. Mode is periodic. A sequence of above is repeated indefinitely. An initial count of n results in a square wave with a period of n clock cycles. So the period of square wave will be n clock cycles. And then here the discussion with the gate. So gate is equal to 1, it will enable counting. Gate is equal to 0, it will disable counting. If gate goes low for a while, out is low, the out is set high immediately. So no clock pulse is required. A trigger reloads the counter with the initial count on the next clock pulse. Thus the gate input can be used to synchronize the counter. So for the timing diagram, this discussion will do and then see the timing diagram. After writing the control word and initial count, the counter will be loaded on the next clock pulse. This is same. This allows counter to be synchronized by the software also. Writing a new count while counting does not affect the current counting sequence. If the trigger is received after the writing a new count but before the end of the current half cycle, the square wave, the counter will be loaded with the new count on the next clock pulse and counting will continue from the new count. Otherwise, the new count will be loaded at the end of the current half cycle. Let us see the timing diagram. So here you can see the control word has changed to 16. The count is 4. So the out signal, it will be say for half of this 4 and it will directly go to 2. So here it will be high, and then for 2 clock pulses it will be low. Again for 2 clock pulses it will be high. So we'll get the square wave. And here as the count is 4, so of the period of the square wave will be say 4, that is n. Then the second case here, we are taking the count as 5. So 5 is the count. That's why what will happen when we load the count now, here for 2 clock pulses it will be low, and for 3 it will be high. So the period will be say 5 only, that is n, but the duty cycle it will be on for 3 clock cycles. Then in this case the gate is going low, the count is 4. Now when the initially it is loaded, the counting will start 4 2, so it will remain high, and then again for this it will go low. Now when the gate goes low, immediately this will become high. Then when gate becomes high, the counting will be resuming. So here you can see here it is 4 2 2 2. Then when gate becomes high, the counter register will be loaded with the count 4, and then it will remain high for 2 pulses, and then it will remain low for 2 pulses, like this. In this way we can generate the square wave using mode 3. Then mode 4, software trigger strobe. Out will be initially high. When the initial count expires, the out will go low for 1 clock pulse and then go high again. The counting sequence is triggered by writing the initial count. So here we have to trigger it with the software. So gate 1 enables counting, gate 0 disables counting, it has no effect on out. So for the timing diagram, after writing a control word initial count, the counter will be loaded with the next clock pulse. This clock pulse does not decrement the count. So for an initial count of n, out does not strobe low until n plus 1 clock pulses after the initial count is written. So it will not strobe low until n plus 1 clock pulses. Then if new count is written during the counting, it will be loaded on the next clock pulse and counting will continue from the new count. Let us see the waveform. So here the control word has become now 1 8 and the count is 3. So gate is high, this is the clock, and now here the out is high. Now after this the counting will start 3 2 1, and when it becomes 0 it will go low for 1 clock pulse. Then here the second waveform, the count is 3. Now gate is low initially, so there will be no decrement of the count. So 3 3 3, like this. When gate becomes high, the decrement will start. The counting of the decrement of the count will start. So it will become 3, then 2 1, and when it becomes 0, we will get the low pulse. So this is the triggered strobe. Then the last waveform, here we are loading the new count 2 after the first count 3. So you can see 3 2 1. Now before that we are it becomes 0, we are loading this count, so that's why we will not get a low pulse here. Instead of that, it will again decrement to 1, then when it becomes 0, we will get the low pulse. In the way the mode 4 will work. Then last, hardware trigger strobe. The out will be initially high, counter will be triggered by rising edge of the gate. When the initial count has expired, out will go low for 1 clock pulse and then go high again. Then this discussion, after writing the control word, the counter will be not loaded until the clock pulse after a trigger. This clock pulse does not decrement the count. So for initial count of n, out does not strobe until n plus 1 clock pulses after the trigger. So this is again hardware trigger strobe. So it will be given by the gate. The trigger results in the counter being loaded with the initial count, the next clock pulse. The counting sequence is retriggerable. Out will be strobed low for n plus 1 clock pulses after any trigger. So out will be not strobe low. So gate has no effect on out. So again the same discussion for the new count. The current count sequence will not be affected if trigger occurs after the new count written, but before the current count expires, the counter will be loaded with the new count on the next clock pulse, and counting will continue from there. So again, let us see the timing diagram so that it will be clear. Now the control word has become 1A and the count is 3. This is the clock, and here gate acts as a trigger, hardware trigger. So now out it is initially high. Now after loading here, you can see the count will start, and here the gate is we are giving a pulse to the gate, so we are giving the trigger, then only the counting will start. 3 2 1, then when it becomes 0, you will get a low pulse. Again we are giving another trigger, so the count here again it is loaded with 3 and it will continue, and when it becomes 0, you will get a low pulse. So this will be repeated again. Then in second case, we are giving the trigger before the count expires. Just see, here the count 3 is loaded and here we are giving the trigger. So it will become 3 2. Again we are giving another trigger here. So again the counter register will be loaded with 3, then it will be decremented to 1, and then when it becomes 0, you will get the low pulse. So we will not get the low pulse unless and until this becomes 0, count becomes 0. Then in the last waveform, we are loading the second new count, that is 5. First old count is 3. So here you can see this is loaded here. We are giving the trigger here. So it will be decremented by 2 1 0. It will go low for this case, and then when we give another trigger, the count will be loaded here, 5 4, like that. So in this way the mode 5 will work. So with this we come to the end of this video. If you have any questions, you can find me at Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon for notifications on future videos. And thanks for watching.